All right, let's dive right in and talk about the atom. And I mean really talk about it. Because I want you to just forget everything you learned from those simple diagrams in high school science class. The reality of what makes up, well, everything, is so much stranger and honestly way more profound than you probably ever imagined.
So when you picture an atom, what pops into your head? I'm guessing it's that tiny little solar system, right? You've got the nucleus as the sun, and these little electron planets just whizzing around it. Yep, that's the classic image, and it is completely, fundamentally wrong. So today we're going to tear down that old picture and replace it with something that's, well, it's a whole lot weirder, and trust me, way more interesting.
Okay, so here's the first major mental shift we have to make. An atom isn't mostly empty space. Nope. Instead, what you have is a dense, positively charged nucleus, but it's surrounded by two distinct, overlapping fields. Seriously, forget about tiny billiard balls flying around. We have to start thinking about these invisible, energetic fields that literally fill all of space.
So this new model gives us two fundamental kinds of fields. You've got the electronic field. That's the field for all the stuff we think of as matter. And then you have the optic field, which is all about force. Light, magnetism, that kind of thing. And here's the key. Every single atom is a combination of both of these fields.
Okay, so if everything is just fields, then where the heck do particles, like electrons, actually come from? Well, this is where it gets really wild. The answer is that particles aren't really things at all. They are just vibrations. Think of them like ripples, or little focused knots of energy within these underlying fields.
Let's zoom in on the electron. We always picture this tiny little ball, right? But it's not. It's really just a stable, repeating ripple in that electronic field. It's kind of like a single, sustained note being played on a cosmic guitar string. And that specific note, that vibration, just happens to have a negative charge and very little mass. And that's it. That's the fundamental building block of matter.
So these electron waves aren't just out there doing whatever they want. No, they're drawn towards that positive nucleus, and they settle into these very specific energy levels we call orbitals. You can think of them like stable standing waves, like the cool patterns you see on a vibrating drum skin. And here is the most important rule of all, the one that makes our world possible. Only two electrons can ever fit into a single orbital. That one simple rule is literally the reason chemistry exists. It's what forces atoms to bond and create, well, everything.
So you might be wondering, why do electrons build solid stuff, matter, while photons just act like pure force? It all comes down to one single bizarre property: symmetry. You see, electrons are, well, they're fundamentally antisocial. They absolutely refuse to be in the same state as another electron, which forces them to stack up and create structure. But photons, they're the exact opposite. They're super social. They love to bunch together in the exact same state. That's actually why a laser beam can be so incredibly intense. It's just one simple rule of behavior that creates the entire difference between a solid rock and a ray of light. Amazing, right?
But hang on a second. Let's think about this. If all we had in the universe were these antisocial electrons and the social photons carrying forces between them, what would that universe actually look like? Well, I can tell you, it would be an incredibly simple and a very, very boring place.
Yeah, in a universe with just those two fields, you could only make one kind of atom. And it's this thing called positronium. What is it? It's just an electron orbiting its antimatter twin, a positron. That's the whole shebang. No carbon, no oxygen, no gold, just this one simple, exotic little thing.
And get this, here's the kicker. This one and only possible atom is ridiculously unstable. It annihilates itself in a flash of energy in less than a billionth of a second. Blink and you miss it, times a billion. So that leads to a pretty big question, right? What gives? Why is our universe filled with all these stable, complex, diverse atoms, and not just constant flashes of disappearing positronium?
The answer is the nucleus. But it's not just one kind of nucleus. There are over 250 different stable varieties out there, and each one acts like a unique heavy anchor, giving the electron fields something to organize around in all these different ways. This is the secret ingredient. This is what gives us the entire periodic table and all the beautiful complexity we see in the universe.
Okay, so we've established that the nucleus is pretty much the hero of our story. But what even is it? Let's zoom way in and take a good look at the chaotic heart of the atom. All right, let's start with the simple view. The one you probably saw in a textbook. It tells us the nucleus is this neat little bundle of protons and neutrons, all held together by some other particles called pions. It's a nice, tidy picture. But it's just the surface level. The deeper reality, oh, it's so much more chaotic.
And here it is, the big reveal. The nucleus isn't some calm collection of well-behaved little particles. No way. It is a roiling, churning, chaotic swarm of fundamental quarks and the gluons that bind them together. It's a place of unbelievable energy and activity, not some static thing built out of Lego bricks. And guess what? Just like the electrons, these quarks and gluons aren't little balls either. They are also just discrete waves, but in their own special fields. The only reason they form stable, recognizable things like protons and neutrons is because they're all resonating together in this incredibly complex, collective dance. It really is. Fields all the way down.
So where on Earth did this incredible variety of stable yet chaotic nuclei even come from? Well, for that answer, we have to zoom way, way out, from the heart of a single atom to the very beginning of the universe itself.
The truly mind-boggling truth is that none of it, would exist without a very precise chain of events that happened in the early moments of the Big Bang. That incredible cosmic fire is what forged the 250-plus stable nuclei that are now the foundation for every star, every planet, every single one of us. That chaos you find inside every atom, it's a direct echo of the birth of our entire universe.
So the next time you just look at your own hand, I want you to remember what you're really seeing. You're not looking at solid particles. You are seeing the entire history of the cosmos, written in the language of vibrating fields and the chaotic dance inside every single nucleus. From one single cosmic event all the way to the very fabric of your own being. It really makes you wonder, doesn't it? What other profound secrets are just hiding out there, right in plain sight?